I am now making this video during 4th hour while the rest of you sign on and tell me that you're here or not. Questions from the Nearpod. This was from yesterday. I will post this. You'll have to go through it on a self-paced lesson, but don't worry too much about it. If it was like, if you were given this, what's this? Oh, hey, I'm making the video that you just requested. I'm making the video that you just requested. So what you want here is, so this is false, and the reason that this is false is because if you were actually going to do a squared, you would want a times a and if you actually multiply this together, you're going to get this, which is not the same. So make sure that you are aware that these are not the same. You do actually have to multiply the matrix by itself. And so in this case, it's only the -7 that disagrees, but it doesn't matter. Anything that disagrees, disagrees. Then I gave you a question. It was like, here, this is K. And I said, what's K inverse? And it was a trick. And here's why it's a trick. You do want to switch these two. So like A is right in that. And you do want to switch, this is going to be a positive, this is going to be negative, so A is also right in that. B is if you just mix up those instructions, but you cannot forget that there is a scalar that goes out in front of this. So if you have any matrix, A, B, C, D, here's the inverse, 1 over AD minus BC, and then you switch the A and the D, and you make B negative, and you make C negative. And then this thing that I've circled in yellow is what we call the determinant. And the thing that it has a couple of different meanings and a couple of different things we care about, but in general, if the determinant is 0, there's no inverse. That's the most useful thing for you right now, because if we had 1 over 0, that's bad news. If a matrix is more than a 2 by 2, use technology to get this. You can definitely make your calculator do this, and on Desmos, there's like literally a button that says det. If you go to desmos.com/matrix. And then this would help you get, if you had like a 3 by 3 or something, it'll tell you the quantity that is the determinant. Well, let me know if you have questions. And then the last one said, here's P, and then here's the transformation matrix. And I asked you what it is, and if you do this, what you get is this. And basically what it does is it switches your X and Y. And I was just trying to see if y'all were okay with that. Cool. Let me know if you have questions. Okay. Markov chains. Markov chains are basically a thing that looks at when you can predict something, basically a 2 or a 3 situation state, and you can predict it based on what things are happening. So let's say it's dry today, meaning that there is no rain. So dry, no rain, or rainy, it rained at some point today. Rained, that's how you write an N, no worries. Up here, what we're going to call, this is called our current state. And then on the other side, we're going to have our future state. And I'm going to say, if it is dry today, we have an 80% chance that it's going to be dry tomorrow. If it's dry today, we have a 20% chance it's going to rain tomorrow. If it's rainy today, we have a 40% chance that it's going to be dry, or a 60% chance that it will rain. So the idea being, if it's raining, it's more likely it will rain tomorrow, but not like that much more likely. One of the ways that you could figure out, like, what's it going to be like in 2 days, is you could make a gigantic tree diagram. So you know it's dry today, then you've got an 80% chance of dry, 20% chance, and then here it changes because if it rains, then it's 40 and 60. If it's dry, it's 80 and 20. And let's say I want to know what's it going to be like in 2 days, what's the likelihood it rains, then I need this path, and I need this path. So 80 and 20, 20 and 60, that gets a total of 28% chance that if it's dry today, it rains tomorrow. 28% chance that if it's dry today, in 2 days, it will rain. Okay, so you can do this, but if you're going to ask for like 15 days, this is going to suck. It's just too much. You don't want to do it because it's too many things and you don't want to do it. So what you can do is you can use a matrix like this. I just called this matrix K for, yep. K squared would just be matrix K times matrix K, and you get this thing. And this would tell you, okay, if it's dry today, the likelihood it's going to rain in 2 days, because the 2 here is going to be 28%. And then, of course, you can see if it's raining today, the likelihood it's going to be dry is 56%, etc., etc. So this will help you, and this is going to be way easier because if you wanted to say, I don't know, 50 days from now, and yeah, weather doesn't work like that, but maybe it did, what you can do is you could just raise this instead of 2, raise it to the 50th and make a calculator do it for you, and then boom, you have your percentages. So, second example, bicycles. Y'all know what like nice rides are, right? Where they drop off a whole bunch of bikes and then you get to drive them around. So in your book, this is page 404, and they use silly like outer city, inner city, and central city. I don't know what the difference between inner and central city is. It doesn't matter. You could think about this if you wanted as like north and south and east, and we apparently don't have a west part of our city. It doesn't matter. Here's a graph that kind of describes what's happening. So look at just the pink right here. If a bike starts in the central part of the city, there is, according to this, a 50% chance it will end up in the central part of the city. There is a 30% chance it will go to the inner part of the city, and a 20% chance it will go to the outer part of the city. Similar, if you look at the black numbers here, outer, 60% chance, etc. And you can go through and look at this entire thing again, page 404, example 10. But this then becomes the matrix that you can use. So like this number right here would mean that there is a 30% chance that a bike that starts in the outer ends up in the inner after 1 day. And then if you want to figure out what happens after like 15 days, you could just take this matrix and raise it to the 15th power, and then you could find that out. So these are kind of nice because they let us look at like long-term behavior of things that behave like this. Now, again, not everything behaves like this, I get that, but absolutely, if you're running Nice Ride, you're using matrices like this all of the time because you're figuring out like, oh, during the week, bikes behave like this. Maybe during the weekend you have a different chain, and then that helps you know if and where you might need to move bikes or how many bikes you should start in a place, etc., etc. Last part of the lesson you'll get is investigation 10 on page 407. And basically what this does is it's like you've got this matrix B, or you've got this matrix C or D, or I think there's A, B, C, and E. It gives you a matrix, and then it asks you, can you please make that to the 2nd power, and then the 3rd power, and then the 50th power, or whatever. And it wants you to do that with all of these matrices, and what you're going to notice is different things happen as you're raising these things to powers. Sometimes you'll end up where like a to the 50th and a to the 51st look identical, right? They're basically the same because it's just following this nice pattern. Sometimes you'll find it's like, oh, if it's even, it looks like this. If it's odd, it looks like this. And it kind of oscillates back and forth. Go through and do this actual investigation. Let me know if you have questions.